Hello. Just waiting for people to get in. So, I am working on Nerf Blaster. Yes. Yep. That's what I'm doing. Working on a project. Yep. Can you make the model do a spin? Yeah. Oh boy, it went upside down. Yep. There you go. Hi everybody. Hope everything's going well for you today. I got not enough sleep last night, so I am a bit loopy, but I'm gonna do some blaster work anyway. So yeah, working on stuff. In the live stream yesterday, I think. Did I do a live stream yesterday? I've lost track of time. I think it was yesterday. 2 days ago. Don't know. Whatever my last live stream was. I started work on this. This is a HPA, so air-fed blaster that uses silly shells. And last stream, I sort of got the stuff laid out a little bit and began working on the magazine. Since then, I have mostly finished the magazine. So this is a detachable box magazine for silly shells. And as you can see, looking pretty good. I designed it so that you can feed the shells from either direction. So the shells can either feed this direction if you want it to work like a battle axe magazine, where the shell stays in the magazine as you're firing it. Or you can feed them the other way, this way. So the barrel would be out this direction, if you want to use a feed ramp. So the shell will kind of go forwards like that until it pops out of the feed lips, and then we'll be able to angle upwards like that into whatever feed mechanism you've got going. And I've designed the magazine to do a bunch of other stuff, so this magazine should be very useful in several different blaster designs, not just this HPA project. Because if I'm making a swappable magazine, I want it to be as compatible with other things as I can make it. So the other things I want to do for this magazine is I want to add some sort of like geometry to the bottom to make it easier to hold in like chest rigs or some sort of gear to hold the magazines, whether that's going to be screw holes on the side to like attach a clip that goes onto a belt, or like adding notches to the bottom so that it can like lock into a little compliant spring mechanism of some type. Who knows? But I'm going to make it easier to hold in gear. And then the other thing that I need to do is I need to add the catch notch to both ends of the magazine for catching it into a magwell. So whenever I decide to add the catch magazine release to this bit is when I'm going to be deciding where the notch should be on the magazine. But I haven't done that yet because I just haven't gotten around to it. So I'm going to do that at some other point. Thank you, Days in Sweatpants. Glad that you like it. Yeah. What's their top fan counter? I have no idea. It's something that YouTube added. I think that's whoever comments the most gets a little thing next to their name. I don't particularly care about it, so so yeah. And then off screen yesterday, I sort of cleaned up some of the files that I was working with, and I extruded this down into a magwell shape, and I hollowed out this piece to accept the new magazines. So it's got slightly different shaping in there, in the sort of chamber area. Sort of cleaned up all this stuff, modified how this bulge is modeled and shaped, so it should print a little bit differently and be nice. And, you know, just a bunch of general cleaning up of the model. And then I also took the grip for the HPA project, the HPA thing pistol, and I moved that to where it needs to be on this blaster. And I did a little bit of stuff up here with that to make that look a bit nicer. So yeah, that's what I've got going on there. And now I'm working on figuring out how to arrange the HPA core. This tube back here is what I'm currently planning on using. My first thought was to just attach the core directly to the breech face and have it slide back and forth whenever you're firing, but Roboman brought up that that might cause issues with the fittings failing over time because they're being twisted a little bit each time that moves back and forth because the tube bends. So now my new thought is actually something that I had tried way long time ago on a different project, is having a tube, which is this tube, attached to the front of the tank, right there-ish, and have that be solidly attached there, and then essentially have like a sleeve over it that travels back and forth. So there's some dead space on it, but it should provide a seal without needing to move the tank itself, which is good. that's what I'm working on. And yeah. Yep. So that's what I'm working on. Had to stop watching early the other day. You've made some real good progress on this. Really cool. You made the detachable magazines dual purpose. Thank you. Yeah. I mean, if I'm making a magazine that people are going to be printing multiple of, I might as well make it as useful in many different blaster types as I can. And it's going to look nicer as well. Like, I haven't really put much thought into like where the viewing ports are right now, and there's no greebling on it. Like, I'm thinking maybe like stripes in this empty space, or like angled stripy bits. I don't know. Something to make it look more interesting. How do you get designs out so fast? Do you work on stuff simultaneously? Yes, I work on a bunch of different projects at once. So I've got tons and tons and tons of projects that I just work on whatever I feel like from day to day. And eventually everything gets done, one little bit at a time. And of course, I do have like main priority projects. Like right now, my main priority is Breacher, getting that out the door. So that's in beta right now. But stuff like that, I do have like focused blasters. But you know, if I work on one project day after day after day, I don't want to get burnt out. So I work on other stuff between that. So yeah. So this is the blaster. I also haven't decided yet if I want to have a stock on this. Yesterday I did try out just going like that, but that looks a little bit wonky. So I haven't decided if that's really what I want to do. But because the pneumatic cylinder right here needs to go somewhere, and I don't really want to put it above the barrel because then it messes with like this top area, and I haven't decided yet if I want to like have it on the side over here, but that would look a bit wonky as well. I don't know. Gonna need some work on that. So yeah. Right. So right now, I need to work on making that tube out the back. So I'm actually not going to use that one. I'm going to use just a piece of barrel material. Right. So this is going to add some dead space to the blaster, but I think it will be fine overall in the grand scheme of things. So right here, right now, I need to modify this piece a bit to get that holder geometry for the Nomad core out of it. There we go. There we go. Very good. Overall, I'm not planning on talking a whole ton about specifically this project today during live stream. I'm just gonna kind of work, and you guys can watch me work. And we'll see what happens. Hopefully Fusion 360 doesn't crash. I actually only need half of this because I can mirror it after. So I'm going to slice that there. So this is easier to work on. Like that. There we go. Boop, boop, boop. Boop, boop, boop. There we go. And boop. Beautiful. Distance there is 3.5. Very nice. What's this outer diameter? 17.5-ish. Nope, radius. Good. SPL style stock might work. Yeah, I guess it could. Immensely hype about the theoretical Breacher Halo shotgun. Yes. Eventually I'll work on that. It's not a right now project, but I've been doing some like preliminary testing to see if the concept works in general. For the Breacher Halo shotgun, it's going to need some different um, changes to like the feeding mechanism to make sure that the shells stay aligned even though the rest of the stuff is upside down. But I've got plans for that. Lengthened bodies remind me of the old MiG rival blasters like the Apollo and Helios. Yeah, it does a little bit when I do that stretched out back end. What happened to the first design? It was different in the first live stream, but this is that. It's just developed over time. It takes time to mash crap together, and this is what it looks like once you get another 1 day into the design process. Yep. Yep. All right. So I'm going to cut this in half. So I'm just recycling parts from my HPA project right now. So what I need here is I need these barrel sealing O-ring geometry bits. So I'm just chopping those off so I can use them without having to remodel them. Boop. And boop. There we go. And then I also need this little O-ringy shape thing here. So go slice that. And then we can get rid of that. And then on this, I can just do a circular shape there. 15. And then slice this piece along that. And then I can get rid of this. There we go. So now we've got the geometry for that little sealing O-ring and the geometry for the top barrel piece. So of course we're not using this barrel to fire out of. We're not using this barrel as a barrel to fire darts out of. We are using this as an internal component to connect the front of the breech face to the air tank, which is going to be moved back here somewhere, without needing to move the air tank around during firing. So this breech component up here is going to be this orange bit here, and it's just going to slide over the barrel back and forth to keep it lined up. Ball bearings are linear rails. In what context? Ball bearings are linear rails. For this blaster, probably neither. I don't think it needs them. But if you mean for springers, I prefer ball bearings, mainly because it's cheaper and easier to design around, but it's also a lot lighter. And in my opinion, linear rail and like the difference between a linear rail and a well-designed ball bearing system is extremely small in terms of like actual feel. So I prefer ball bearings. Are you going to make the magazine double stack? No. I don't want to deal with it. Sounds like a pain. And already the magazine is pretty darn big because these are silly shells. To make it double stack with silly shells, it's going to be even bigger. So I don't want to deal with it. Yeah, ball bearings are linear rails for priming, block, and springers. I prefer ball bearings. So we get that bit like that. Now I need to make sure that this is a good diameter, 16.9. What's this? 16.9, and what's that? 16.7. So I want that to be 16.29 divided by 2. Divided by 2. There we go. So that's all the same diameter. Right there. Beautiful. I think I actually want that to be like that. There we go. So that's just a clean 17 millimeter inner diameter for that hole. Then we've got these two O-rings, and the outside of the barrel is going to be lubricated because it's being used for like a thing, a sealing component. You meant to make the shells slimmer. What? I don't understand. I'm not planning on making a drum for this either. But the thing is, since this magazine is mostly based off of battle axe geometry, someone else made a drum magazine that sort of worked for silly shells. But like if they decided to go and put more work into that, they could easily like attach it to the bottom of these detachable magazines and then make a silly shell drum mag that worked. Drum mags on shells are generally easier than drum mags on darts because you don't need to deal with like dart squishing, like and dart tips like grabbing against the plastic of the shell or the plastic of the magazine. All right, I need to move this component back. So I'm going to make a new group over here. I'm going to find that piece. I'm going to move that into this group here. Hide that. I'm going to find this nomad. I'm actually going to hide all that, and then I'm going to find nomad. Move this, this, all down to that new group. There we go. And that looks like I've got all of that. And now I'm going to show all bodies. There we go. Very nice. No way is that what you think it is. I don't know. What do you think it is? It's not meant to be a bolter. That's just sort of how the shape is lined up right now. But I haven't decided yet if I want to extend the front end, just have like a little Picatinny rail down there, and there's probably going to be a stock on it at some point. But yeah, it's not meant to be a bolter. That's just sort of how it's shaping up right now in this early design process, but that is definitely going to change as I make it, actually work. Alrighty, so now we've got the components for this thing. Let's save that. Yep. Alrighty. My brain no working. So I don't think I need most of that bit anymore. I forget, do I have an O-ring seal at the front of that already? I don't think I do. So I don't think that I really need that. And this thing, this bolt face, prints from that face right there, so I can add the ceiling geometry to the back of it without causing issue, I think. So I think I'm just going to do that, make that one part that slides over the thing. Probably. I can change these to longer screws. Because I've got M3 by 50 millimeter screws now that I use on Breacher. So I can just swap those to those. Yes. Alright. How do I want to do this? So I also need to keep in mind that this flappy lever is going to be trying to poke against stuff, so I need to keep that wall facing it generally smooth. Alright. Okay, so let's start orientating parts. So we've got this. This is going to be sliding like that, along that. Maybe I should try and make this better lined up there. So +4. That. +4. Now what is that? Now. That's not good. Okay. Distance between that and that. Not a clean number. Okay. Let's clean that up. Just for posterity. So I want this this, move that corner to that corner, and then move this backwards 2-ish millimeters. Boop. Combine that and that. Now, what is this? Still not a clean number. Okay. So, that's fine. That's fine. Let's get this to here. Divide by 2. So that's the middle point. And then from here, get 5 millimeters and 5 millimeters. And then cut that along those like that. And I can get rid of those excess bits, and I can make it longer in that space correctly, centered to the stuff. So now this should be a clean number. Yes, 13 millimeters. Let's extend that a little bit more. There we go. 14 millimeters on the dot. Good. Okay. Scroll back up here. Show all bodies. Very good. Make an HPA rifle next. I've actually been considering doing an HPA bolt action rifle, using either 1 nomad core or 2 nomad cores, just for fun. But I'm not sure when I'm going to do that, because I'm going to college in like a month at this point. So I'm going to have significantly less time to work on things. I'm also not going to be at my workshop here at home. So I'm going to have less access to things as well. Alright. This should be flipped around, actually. So, whoop. And then that face, I think, can be that one. Is that lined up correctly? Seems mostly right. Yep. 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 So I'm just chipping away at this. Slow going. So, what part do I want to do next? So I want to have that sealing component be separate from this carriage component. So I can reprint the seal if need be. So let's bump that out by 2. Let's bump this out by 0.5. Oh, I didn't mean to do that. Let's bump this out by like 2 as a new body. Then bump that out by 0.5 for tolerance. And then I can merge that into this. Boop, boop. There we go. Like that. And then give that another bit more thickness. There we go. Okay. Now that crap is going to need to seal onto the barrel. Now, do I want to have it so the barrel is glued into this piece, or do I want to have it so it is O-ringed into that piece? It's going to be sliding back and forth a lot, and I need to keep a good air seal against it. Do I want that to be glued? As opposed to like with a set screw. I don't know. It depends on how much extra space I'll have later. So I guess I don't need to decide that right now. It would be pretty cool if you had a barrel for the silly shells to go into. So, like, on this particular blaster, I'm not planning on it. It's easier to just have it like this, like functionally. It'll work better. Like the darts won't bump around in the barrel or anything like that. But if you're talking about a sealed barrel to like unlock more potential of FPS out of the shells, I have actually like modeled a sealed barrel system for silly shells. I just haven't finished it. Like I began modeling it before I even worked on Battle Axe, so it's at least a year and a half old now. I haven't printed it. because I've been busy making things for normal silly shells. But it was essentially a system that had new shells that would work in previous silly shell blasters, but had like alignment geometry on like the front face of them, so it could line up 2 or 3 chambers of half darts with sealed barrels that would then let those shoot out the front at higher FPS. Yep. So yeah, I am not operating on much sleep. All right, this needs to go here. Now, the breech system on this is going to move back and forth 95 millimeters, which is that far. How long is this barrel? I think I've got it marked on here. Yeah, 5 inches right now. And that's a 0.527 inch ID. So I actually want a 0.509. So 0.509 inch divided by 2 for radius. There we go. Because that is going to help reduce just a little bit of the dead space in here by making that as thin as I can while keeping the same outer diameter. Oh, how did you just teleport the barrel there? So I used the move command, and then in here there's a point-to-point option for movement. Then you can match any geometry from one part to another part. So I've selected this circular bit here of the barrel, and like I can select this circle down here, and it will teleport it so the centers of each circle are lined up with each other. And then I can just hit enter and it stays there. So that's very helpful with lining up stuff. And for example, if I wanted this corner here to be perfectly matched with this corner here, I could just do that, and then those 2 parts are moved. So it's very helpful. Additionally, what I could do is I could use this align tool up here, and that gives a slightly different way of doing that, where it still does it mostly the same, but it takes more into account the position of the part relative to another one. It's like it will flip the part around to match that better. Whereas just the move point to point just moves the part without moving its like angle or like flipping it around or anything like that. Did you get an upgraded HPA core? I'm waiting on Roboman to finish his batch so I can get them. I'm very much looking forward to it. I sure hope that I can get it before I go to college, because it should make the FPS of the HPA thing, Talon-fed pistol, the other HPA project that I've got, it should make that fire faster, stronger, and more reliably. So I'm very much looking forward to getting that on hand. And it should be mostly drop-in for that project, which should be good. I just need to get the thing. What day is today? Tuesday. Okay, so we've got that and that. The barrel is essentially going to be connected to this orange piece so it can seal against it. And then, yeah, so I don't need that piece anymore. Let's hide that. I do need to get these parts into that folder. So let's do that. There we go. So now that's all one big group. I can just move around by highlighting it all and moving it. Is this semi... So this project right here is going to be semi-auto or full auto silly shells with HPA. That's essentially what the project is. It's not a battle axe, because the battle axe is like a different format. Like battle axe is way bigger than this, and battle axe doesn't have the removable mags and all that sort of stuff. So while it is based on like I copied and pasted battle axe's geometry to make this. I do that for like everything, so it's not really a battle axe. But yeah, so it's not. I wouldn't call it a semi-auto battle axe. I would more so call it a semi-auto silly shell firing blaster, because the battle axe components are just, that was the easiest way to get those components into this file. Where is this shell? There it is. Right, so I'm going to move this down here so it is lined up with that. There we go. And then I'm going to move this backwards, just a ton. And then I'm going to work on this up here. So what I need to do here is I can remove that. I'm going to keep the screws where they are for now. I'm going to trim this back just a bit. Make sure that I'm not cutting off anything that I need. And that's just to get this back face a bit smoother. Now I can extend this back as far as I want. Now I'm going to do a cross-section view up here. Will you be able to get out of darts to sell the HPA thing? I doubt it. They don't really want to do HPA because, like, legally speaking, selling HPA has other things you need to take into account as far as I understand it. And it's also just expensive, so like less people are going to be buying them compared to, you know, normal blasters. But I think that I might be able to get someone else to do hardware kits for specifically the HPA thing. Like, I think Roboman could do it. But yeah. Just depends on who wants to take on the responsibility for something like that. Okay, so I would want to have a little bit of wiggle room. A little bit more wiggle room. So right now I'm just lining up the tank and the extension tube, I guess we can call it, to where I would want it to be. So this position here is relative to as if this bolt component was all the way at the back there. But right now what I need to do is I need to hide a bunch of components here. Don't need those right now. Don't need the magazine right now. Don't need the magwell right now. But I do need the bolt components. I don't need these shells. So I'm going to hide those. Right, so this is what we've got right now. And next I'm going to move the sealing O-rings, these things here, to where I want them to be relative inside of this component. What is the aluminum barrel for? So the bolt, this breech face component here, is going to need to slide back and forth. However, I don't want to directly attach the HPA thing tank to the back of that, because that sliding back and forth, while also having more mass, is not a good thing. It also is probably going to cause issues with like the fittings back here getting worn out over time because they're like the tube is bending back and forth and all that crap. So this tube is essentially like a transfer for the air, where this bolt face up here can move back and forth without needing to move the tank in the back. Once I get it moved into the correct position, it will be a little bit easier to understand what I'm talking about here. So we've got this, and I want to position this in a better spot. So I want to position this towards the back of that piece. So we're going to move that to there. And then what I'm going to do is I'm going to actually cut the bolt face component along the front face of that. So let me see if I can get you guys to see what I'm doing a little bit better. So this is essentially what I've got here. What I'm going to to do now is I'm going to mirror that. So it is a circle. You can see it's slightly... Fusion does this every once in a while. It messes up things that are circular and turns them into two almost circles. So I'm actually going to do that to make that into a circle. There we go. Right. Bolt face. So that's the normal bolt face. Whoop, I didn't mean to do that. There we go. And then what I need is the bolt face, this bit. And I'm going to use this bit to cut that out, which is now this thing, which we're going to delete, and then we're going to merge that and that. And there we go. Now we've got a new circular donut with O-ring geometry on the inside to hold those O-rings in place. Very good. Glad HPA has more... Well, I'm glad while HPA has a more niche market, you're still working on designs, current projects. So this shows the potential it has for Nerf, I think. Yeah, I like HPA. I have always loved air pressure blasters. Like, I love the Titan and Supermax and AirTech blasters. Like, back when I've been doing the hobby since like 2010-ish. So, like, up until the era of 3D printing, I've loved 3D printing, or I've loved air-powered blasters. And now that HPA is becoming a lot easier to get your hands on, and there's like better HPA cores that are not, you know, $300 to get the firing component for your blaster, on top of the $200 regulator, on top of the $100 air tank, on top of the $200 air compressor to pump it up yourself at home. Like, all that stuff adds up. But now it's gotten a fair bit cheaper and easier to work around. So I'm glad that now I'm able to actually do HPA as opposed to just LPA, like hand-pumped blaster projects. Do you think that... So, yes, this barrel here is going to have a lubricant on the outside of it. And then this orange component is going to be sliding over the outside of it and acting as like a seal. So you can kind of think of this as like a ram on a caliburn, like staying in place. And then this orange thing would be the equivalent of a chamber in a caliburn, like sliding over it. Sort of. Yes, Mag Strike is fun. I like the Power Clip more than the Mag Strike because it's awesome. It's got like it's a big blue and yellow blaster, and it's got like see-through sides, so you can see all the air bladder and mechanics just flapping about while it fires. It's so cool. But yeah, it's good. All right, so this is the bolt face here, and this is the bolt components. Hide all those and that. Make sure that all this is shown. I'm going to move the bolt face back up to there. There we go. I'm going to save. And next step is figuring out how long each one of these things needs to be in order to function correctly. So if I show... Nope, not that. Oh, wait. Here we are. So I need magwell. Show all the magwell parts. There we are. Very good. Do you think that sniper rifle project, your thing you were making before, could be pressurized air? Like if... yeah, you can convert pretty much any blaster to use HPA without that much problem, but I don't really want to because it's expensive compared to a Springer blaster. But like, if you want to HPA convert an existing Springer blaster, it's relatively easy. What was I doing? Right. So what I'm working on right now is I need to figure out this bolt face thing in comparison to this thing back here, where all of this needs to be relative to each other. So actually I'm going to move this turnaround and these O-rings, or not turnaround, sorry, this piece here, up here into bolt components, so it won't move when I move the air tank. There we go. Beautiful. So this is essentially what it's going to be doing. This air tank is going to be stationary back here, and all of this crap is going to be sliding over that barrel whenever it's chambering and firing a dart. What I need to do now is figure out the correct length for this barrel and how wide the bolt needs to be in order to interface with that correctly. And yes, that is going to have a ton of dead space. But that's just how it's going to be. I meant making that sniper rifle use HPA would just be much easier than spring-powered, but I agree that it's more expensive, which is why I don't like because I'm poor. Yes. Yeah. Like, I like Springer blasters more than HPA, just because it's easier to use them. Like, you don't need to go and get your tank filled. You don't need to, worry about the airline and all that stuff. It's lighter, all that sort of stuff. It's easier to just use Springers. So I like developing Springers more than HPA. However, HPA allows you to do a lot of super funky, cool things, like full auto, semi-auto, while keeping good accuracy, like the HPA thing I'm working on, that other blaster, or like fully automatic silly shells dumping out the front of the blaster, shooting like 400 darts at someone within a few seconds, which would be sweet, which is why I'm working on this. And this thing here isn't necessarily meant to be, commercially viable, sold in large quantities, all that sort of stuff. This is more so meant to be just super cool, and I'll still release it, but, like, you're not going to see hundreds of people building this thing. You're going to see maybe, like, 4 people building this thing, and I'm happy with that because it's cool and I want to build it, so that's why I'm making it. I want to have this in my personal collection, so I'm making it a real thing. Can't you use airsoft barrel diameter for the piston instead of larger tube? Would have much less dead space, wouldn't it? Yeah, but like I don't wanna. I've got tons of this tube on hand, and then also the diameter of the front of the Nomad core. That is not right on the model. The diameter on the front of the Nomad core is like 10 millimeters, and the inner diameter of this barrel is like 13-ish millimeters. So it's like close enough, in my opinion. If I wanted to reduce dead space, I would just go find a 10 millimeter inner diameter tube, like I've done right here. Oh, not right there. I've done right. I don't know. I previously had a tab open with 10 millimeter inner diameter tube, but anyway, I just don't really want to deal with that because then I have to go and buy a new tube. I need to buy like 8 feet of it, and then it's like, if you want to carry this blaster in your shop, you have to go buy a tube that no other blaster is going to use. It's just a pain. So I'm just going to use a barrel. Like Gemini Super Socor. Yes, I agree. I love the look of the Super Socor. It's super cool. Can you shove Nerf dart foam in the barrel to remove dead space? The inner diameter of the foam would not be correct to do so. I guess I could make like a printed piece that could go in here to take up dead space. Now that's not a bad idea, actually. Doing a printed piece to take up the dead space. That's actually a pretty good idea. I like that thought, actually. Doing a printed thing on the inside here to take up the extra space. Let's model that real quick. And then what was the inner diameter that I needed at 10 mil? Let's make that a different color. Let's make that a... Where's my good blue? Nerf blue. There we go. Yeah, that's nice blue. Okay. So this thing will just sit inside the barrel to take up some of the dead space. That's not a bad idea. I like that. thrilling gameplay. I know. It's invigorating designing foam dart blasters. Yes, the most exciting thing you've ever seen. All right. Yes. So I need to get this. I need to go back a bit. Slice that there, and then that. I need to make that diameter. Boom. Boom. I said boom. There we go. And then I can combine that and that back together. And I can make this have a taper of, I like 30 degrees generally, but let's do that there. There we go. And I can make that a bit smoother. Make that a bit smoother. There we go. Cool. Alrighty. So, next step is, so this is the front position of the thingy. Now in the rear position, it's going to be moved back 95 millimeters. So let's move this back 95 millimeters. That right there is the rearmost position of this thing. So what I can do here is I can take all of this Nomad Core stuff and move it up. This should be in that folder. So I can move this up to meet the back of that for the most part, and then give it a bit of wiggle room. Like, say, 3 millimeters of wiggle room, maybe. And now, this moves back up 95 millimeters. Is that right? I don't think that's right. Wait a minute. This whole thing needs to move back 95 millimeters. That means that the tube would be mashing through the front. Yeah, that's not what you want to do. How do you make things be moving like that in Fusion? I just hit the M key for the move tool, and I just drag it back and forth. Yep. All right. I recall this being an issue when the last time that I tried this. I tried this previously for a magazine-fed short dart blaster. The thing that I tried before the HPA thing came around. Like 4 or 5 HPA projects backwards in time. I tried something like this, so let's see if I can figure this out. If I can't figure this out, then I'll probably just like move the tank down here and have an O-ring that spits up and then shoots out. But that would be harder to align. That's the only reason why I haven't done that quite yet. So what do I want to do here? Like, the best solution for this would be to have like a collapsing corrugated tube connected between that bit and that bit that somehow magically telescoped in and out of itself perfectly without kinking up or jamming up every single time that you moved it back and forth. But we don't live in a perfect world, so I need to make this work. How do I want this to work? Okay, I need to think through this a bit. This bolt face, I'm going to make a copy of it as like a dummy. So, dummy bolt face. This is going to be moving back 95 millimeters, but let's just say it's going to be moving back 99 millimeters because there might be some over travel. So in actuality, the barrel for this is going to need to be there. And that means that this would then have correct amount of clearance. And that means that this would need to move back here so it meets up with that. So that's what that would be. That looks horrible, honestly. That is so much dead space between the air tank and the shell. Ew. But to be fair, this is sort of how some old HPA projects other people did worked. Nerf HPA Recon. Is this the thing I'm thinking of? From Kaba Builds? Let me see. I've muted my thingy. Nope, that's when they had a supercore. I recall back when people had HPA blasters before they had supercores and stuff like that, they had a system just like this where they used like an XBZ at the back, XBZ air tank, and just had tons of dead space just like this. This thing here. I think that this is what I'm thinking of. Like, look at that. That is essentially what I'm trying to do right now. So that was like a brass breech that they had sliding back and forth back there with tons of dead space. Do they have an inside shot of this? No. But yeah, that's essentially the same thing that I'm doing here. This being a stationary air tank, and that's firing up into this brass breech, and then this just slid back and forth, and then there was all of that dead space there just existing. Just saw this post on Facebook today. Looks awesome. Cool. This would be what finally got me to buy an HPA setup. Cool. Gears, maybe. Gears would not help in any way in this system. The issue is not the amount of movement back and forth in terms of like the operating mechanism. The issue is keeping the air sealed throughout that whole length without causing issue. A vacuum hose tube. Yeah, like some sort of corrugated crap, like that would just like collapse back and forth would be really nice. But like having that do, hundreds or thousands of cycles back and forth, it's just not going to work well. So it's got to be all hard components doing the moving, hopefully. So let's figure out what I'm doing here. Let me ask Roboman how much dead space issue this is going to be. I'm not a fan of having this much dead space, but it might just be what needs to happen. All right. What am I doing? So this bolt face is going to need to move back and forth 95 millimeters. That's 95 right there. So that would work. Yeah. So move this back this crap can all move forwards a bit. So I can actually just measure that. Can go forwards 14 millimeters. Okay. So what I'm going to do here is I'm going to make these both shorter by 14 millimeters. And then just move everything here from the Nomad forwards 14 millimeters. There we go. Maybe you could put a piece like the telescopic ram of the Nexus Pro. Nexus Pro internals. Google. So that's essentially what I'm doing here already. Like the telescopic ram. That's essentially what's going on here. But it just adds dead space, which I don't love. You could have aluminum tubes that could feasibly seal if they were half the length of the current setup. They could possibly collapse into each other. Hard to actually get that sealed out exactly. That's the problem. The sealing is the issue. Yeah. As far as recoil goes, this is already going to have recoil because it's like flinging this heavy hunk of plastic back and forth already, plus the weight of shells, plus it like slamming up against the back, so it's transferring that momentum back into the frame of the blaster. There's already going to be recoil, so I'm not massively worried about that. Like, I'm going to have probably a front grip on this, or like at least a tall magwell where you can jam your hand up against it to hold it in line. And also, it's a shotgun. It's a shotgun. It's a full auto shotgun. Like, losing accuracy because of recoil making this bump up is not a concern. So, yeah. They're already on board, yeah. Like, recoil is a feature to some people also. Like, I don't know. I'm indifferent towards it. Alright. What am I doing? Yeah, it's full auto. This is going to be full auto and semi-auto. I think I mentioned that previously. Right. So this is going to be moving back and forth like this. 95 millimeters per shot. Firing a shell, moving back 95 millimeters, ejecting, and going back forwards 95 millimeters. Bam. Just like that. Right. So the other thing with having this wider outer diameter of tube is that this super wide diameter up here is tons of extra dead space than if it was thinner. So I might go back to trying out a thinner diameter of tube for this thing here. Yeah. All right, let's look at McMaster Car. Hello, McMaster Car. What you got? What you got? What you really got? You've got mail. No. You've got 10 millimeter inner diameter tube. Polycarbonate. There we go. Now, what's the cost of 10 millimeter inner diameter tube? So an inner diameter 10. Wow, that is a lot of numbers. 10 millimeter tube. Do you have a metal tube that is 10 millimeters in diameter? Yes. What is 10 millimeters to inches? 0.4 inches. So what's close to that as well? inches inner diameter. Does that give me any other options? You can use cardboard tubes. You could also use glass. Yeah, let's use glass tubes in my blaster. That's gonna go swell. Quartz glass tubes. Perfect. Yep. Alright, so tubing. You got steel. That's expensive. However, what's the OD if you use steel? 12 versus 15. Aha. That's a fair bit thinner. Interesting. I don't... Wait, is this the same as that other thing I had up? Yeah. Okay, so that's it as polycarb. This is it as... Oh god. This is it as other stuff. You could make that big part go inside the aluminum barrel instead of sliding outside of it. So I could, back on this thing, they're saying to make this sliding portion go inside of here, which could work. However, that would then mean that there's like dead space issues in that, or not dead space issues. There would be like restriction issues from the tube having to be thinner in order to fit within that. And then you're just flipping around the issue, as opposed to this front area being super wide and this back area being thin. It would be the front area being thin and the back area being super wide. Like, you're essentially just taking this and flipping it around on its back. It's still going to cause the same issue. Put quarters in your old blasters to make recoil. Yeah, exactly. Do you make another low hardware blaster other than the LHTCU? I have one called Underdog that I'm working on a little bit. It's listed in the it's on my YouTube channel, Underdog. It's not quite as extremely low hardware as the LHTCU. Like, it has screws. But other than that, it's going to be pretty much better than the LHTCU in every way. It's going to have... it does have screws, but it's got printed plastic rollers to make the prime smoother. You can use either a printed or a normal metal barrel. You can use elastic to fire it, or you can use a spring. You can use a normal plunger tube or a printed plunger tube. And there's a bunch of other stuff, which is cool about it. So yeah, Underdog. That's going to be my new low hardware blaster. But I haven't worked on the Underdog in a while because the Ontos just came out, and that looks pretty darn good in terms of low hardware blaster. But I am planning on finishing the Underdog eventually. Yes, wouldn't it still make it a little less dead space? I don't think it would. Like, maybe a little bit, but it would trade that, like, just a little bit less dead space compared to the current system, but it would, like, be more fragile and stuff like that. So I'm not sure if I really want to try that. Right, so what was I looking for? I was looking for aluminum. Excuse me. Aluminium tube. I don't want literal, like, flexible bendy tube. I want round tube. Maybe this. I guess I can check this out. Rigid. Yeah, that's what I want. Rigid aluminium tubing. Thin wall, aluminum, unthreaded, pipe, nipples, and pipe. Thin wall. That sounds good to me. Well, actually, I should be checking this out. So, I want pipe that has... What is this? Is this inner diameter or outer diameter? For unthreaded pipe, measure the OD. Gotcha. So I want an OD of, what's 1/8 of an inch? That's really thin. So what I want an OD of, I don't know. How thick are the walls? Oh, I can sort by ID on that. I cannot on this. Oh wait, yes I can. Here we are. OD and ID. So an ID of something like 0.4 of an inch. Which looks like that. Dang, that's expensive. Wait, what? Oh, that is 4 inches, not 0.4 inches. No, I don't want that. I want okay, so that's just essentially aluminum barrel material once you get up to that size. What is this in terms of millimeters? 0.364. That's almost 10. Not sure if I love that. It would need to be 6 inches. Oh, and it's like $10 per each piece of that tube. I don't think that's going to work out. So let's close that. This is a different tube now. So I wanted 0.4-ish ID. This is rigid tubing. Good. Short straights. What's the length of this? 6 inches. Cool. What's half-inch OD? Okay, that's just essentially the same as barrel material. Almost 13 millimeters OD. Actually, no. Barrel material is 16 millimeters OD, isn't it? Okay, so that's actually a fair bit thinner. Half-inch OD. What was the ID? Inner diameter, 0.43 inches. So that's 11 millimeters inner diameter on that tube. That seems pretty nice to me, actually. I need to check something on Breacher for the beta testers real quick. Breacher. This looks so cool. Thank you. You could put geometry inside the printed parts of the bolt so that the cross section remains the same as the ID of the tubing, so that overall dead space could be reduced. Put geometry inside the printed parts of the bolt. Geometry inside the printed parts of the bolt so that the cross section remains the same as the ID of the tubing. Overall dead space. I don't think that's how. Yeah, it has to slide over the end of the tube. Yeah, that's not how things work. Brass tubing. Brass is a bit fragile. I don't really want to mess with it. Why does it need to be aluminum? It doesn't. I'm just looking for something that has a thinner wall thickness so I can get the least amount of dead space out of it without causing it to like snap. Hi, Andrew Pickrell. How is it going? Right. So, this screw here is this M3x50. Yes. Confirmed. M3x50 screws for those holes. Yep. Alright, back to this. Some of the beta testers for Breech are finally getting to assemble the blasters. Woo, exciting. Can't wait to see people actually fire breachers. Hey. Alright, right, so tube diameters. So this is what? This is 1/2" OD and 11 millimeters-ish ID. What was 1/2" OD? 0.5 inches, 12.7, okay. And then what's this in comparison to that? How rigorous is your testing for blasters? Like, what's the system, if you're okay with asking? I essentially build a prototype of said blaster, and then I dry fire it a ton over the course of like a week, while also making it functional, you know? And then I just treat them like crap. And if they survive that, then I'm usually happy with it. Like, I think I've posted previously videos of me dry firing Battle Axe and Excalibur. I just like, destroy or attempt to destroy the blasters. And if they survive that, then it's probably fine. So freaking oh, and also like in terms of testing, for like a beta tester, I just send people the files and tell them to use them in games. Like durability testing is what I do, and like functionality testing on a basic level is what I do. But like if I want it to be run through like 15 Nerf events collectively, then I just send it to beta testers, and then they build them and use them in games. And that's when you like are able to iron out like the edge cases and like, hey, it jams if you hold it in this particular way or something like that. That's when you get to solve those. So freaking excited for Breacher. Good. Glad to hear it. Yeah. I'm looking forward to the Breacher release at the end of August. I really hope that it, like, both that it goes well in terms of, like, smoothly. Like, I hope that the blaster is functioning correctly at the time of release, and, like, people are able to print it, and, like, Printables is happy with it, and all that stuff. But additionally, I hope that it becomes super popular, because I'm going into college actually a week before Breacher releases is when I'm going to college. So I want both to like not have to worry about the release a ton while I'm also doing my first week of my first year of college, which is going to be stressful, I assume. Like I don't want to have to worry about the Breacher stuff, but I also like I'm going to be going to college. College costs money. If Breacher becomes super popular and I make like, I don't know, $5,000 in a month, that would be pretty darn awesome. That would mean that I could just like pay for a chunk of my college, just like right off the bat. That would be sweet. So yeah, funding college via Nerf Blaster money would be exciting. Man, lots of chat. Do you need full version of Fusion to design Nerf or similar? How does the free personal version work? The free personal version works fine. I mainly have the full fat version of Fusion, mainly because like once you get past a certain amount of income that you make from things made in the program, you technically need to buy a license. So I did that. But in terms of like functionality, the free version works fine. Like, you don't have access to some of the weird funky tools that make things like complex geometry possible, but other than that, it's perfectly serviceable. Like everything up until the Cynthia, like every Blaster project that I made up until the Cynthia was made on the free version of Fusion 360. So like the Slab, most of the Cynthia, the Thumper, Silly Max 1400, all those things were made on the free version of Fusion before I upgraded it. So like it's serviceable. It works fine. Oh my god, so many comments. Blasters are probably loud enough when dry firing that you should wear Air Pro. Yes, I wear headphones with noise canceling on whenever I'm doing the crap loads of dry firing. Like, I dry fire a blaster for solid 10 or 15 minutes straight without pause. It's also a nice arm workout because it's usually like K25 or K26 springs. I've tested out dry firing my battle axes, even fallen off a high shelf, and it works great. So, like, don't dry fire it, please. But, like, it won't break, hopefully, when you dry fire it. But, like, don't do it. It's just not good. But I'm glad to hear that's durable for you. Yeah. Battle axe has been a tank. Good. Like, I on all of my blasters, I make the walls and stuff pretty thick, and I make all the print settings pretty overkill compared to, like, what you technically would need to make the blaster work. Because I want it to be strong. I never want to worry about people, like, coming to me. It's like, hey, my thing split along the layer lines. It's like, no. Make it 100% infill. It'll work fine. If it weighs 5 pounds, good for you. And, like, aluminum bars and stuff like that help with structure. 3D printed the slab and you love it? Good. Glad to hear it. Thank you. How do you generally name your blasters? I essentially have a running list of just crap loads of names of blasters that I just come up with, and I just post them in a Discord channel for myself. Like, whenever I think of a word and I'm like, hey, that could be a blaster name, I just dump it in this thing, this list of tons of blaster names. And then whenever I finish a blaster and it's like, hey, this needs a name, I just go to that list and I read top to bottom, like 4 years worth of random names I've come up with until one kind of clicks. Yeah, would be badass to pay for college with Breacher money. That would be awesome. Breacher definitely feels like this thing that people have been excited for a long time, but yeah, it seems like people have been excited for it for a long time, but I'm not sure how much that excitement is going to transfer into actual sales. Because additionally, like, especially recently with tariffs and stuff, hardware cost has gone up a chunk. So, like, a blaster that used to have a, I don't know, $65 hardware kit is now like a $75 or an $80 hardware kit, which sucks. But that's just, like, how much hardware manufacturers are cost, like how much they charge now. And when I say hardware manufacturers, I don't mean out of darts. I mean, like, the factories manufacturing the tube that out of darts then has to buy and cut to length and stuff like that. Like, the raw material cost is going up, which sucks. So, not sure how much Breacher is going to cost at this point. I was planning for, like, a $70 hardware kit, which would have made it just $5 more expensive than an Alchemist at the time. But now, Alchemist hardware kits are, like, $75. So, like, a Breacher hardware kit might be $80, $85. I don't know. It sucks, but I just, like, can't predict it at this point. Spring Thunder, Shotgun Blood. Yeah, since the Spring Thunder, people have been asking for better, bigger pump action tube fed shotgun. Does a piece of your soul die whenever someone dry fires your blasters? Nah. I'm just like, yeah, it's durability testing in the field. Like, whenever I drop a blaster, like, off a shelf or something, I don't go, oh crap, it's gonna break. I go, durability testing. And if it breaks, then, like, just make that part thicker, and then it will work great. And that's why I'm, like, not careful with, like, when I drop silly shells onto, like, asphalt or concrete floors or anything. Like, I abuse my blasters. I throw them into a big old pile. Like, up until very recently, I'd never had any like storage shelves for my blasters. I just had like a big, like industrial sized trash bin, and I just dumped all my blasters in there. So they're like mashing up against each other, and like iron sights are snapping off each other and crap like that. Um, but yeah, it's just durability testing. Fell face first onto your battle axe at HVZ last February and is perfectly fine unlike the rest of your gear. Durability of your blaster is unmatched. Thank you. Thank you for durability testing my blaster with your face. Big fan. Hope your face was okay. Yeah, stuff ain't free. Yeah, exactly. That's one of the things that I've been dealing with the, going on a tangent of a tangent right now. One of the things I've been dealing with for the Breacher recently has been I made those extended magazine tubes out the front that extend the capacity of the magazine tube. So if I open this up here, that's the muzzle. This. Been working on these. And these are essentially just... Oh, excuse me. These are essentially just a tube that is glued into the muzzle. However, I've been working on making sure that this muzzle is durable enough to like handle this tube, because the Breacher itself is already pretty long. Once you extend it out by 2 shells, so it's a 6-shell magazine, it is really long. And that's one of the reasons why this giant plug on the end is so, like, if you mash it up against someone, they'll see it coming, because it's a big orange glow stick that's going to be swinging around corners and crap, like whacking into walls. Because this is long, and because of the way that it's like positioned in the blaster, it's sort of kind of out of your view. Like if you're in a firing position, can't quite see the end of the extended tube. So like if you're walking around a corner, I'm expecting tons of people to just whack this against the corner before they like get a feel for the actual length of the blaster. So that's why I've had to design this connection mechanism here to be extremely strong, or at least as strong as I can make it. So already this is, a super thick wall here. This is 8 millimeters of plastic there. But additionally, this is all have sunbursting throughout it. So it's got these little gaps here, and that forces the slicer, when you're slicing the 3D part, to put extra walls there. So while the rest of this muzzle piece is printed at like a lower infill, that whole wall around that extended tube is going to be printed at essentially 100% infill made out of walls. So I'm hoping that it's strong enough to withstand people walking into a wall with the tube and like whacking it against stuff. But like, I think that it might snap along layer lines at some point if you're not careful. But I don't know. And, it's not a giant deal because this muzzle is, like, hot swappable. It's got heat set inserts for the screws and crap, so you can, like, take that off and just put on the shorter muzzle. And then, like, if the super long one breaks, you can just print a new one and put it on. But, just thinking ahead for stuff like that. What diameter barrel do you need for rival rounds? I don't remember off the top of my head. Captain Slug found a adequate barrel for stuff. Like if you're talking about a printed barrel, you could just use the inner diameter of my rival ball shells. Maybe loosen it just a little bit if you want it to be a long barrel. Yeah. 4-shot tube and top it off frequently. Yeah, exactly. Long bolts to reinforce the extended muzzle. Like I considered that, but I don't think. Well, first of all, they wouldn't really fit well. Like aesthetically, they wouldn't fit well in terms of like the actual size of the thing, and also it's adding more weight to the blaster and more cost of hardware kit, and like the bolts wouldn't be used anywhere else on the blaster. So like it's then like, hey, you're just adding random crap just for this one bit that some people aren't going to use, so they're going to have leftover stuff, just all that sort of stuff. All right, refocusing back on HPA silly shell thing. Back to finding a good sized tube. 10mm ID, 12mm OD. What is the ID and OD of this? This is 13, or this was 11mm ID, and It's 13 millimeters OD. What was the OD of this? 12. So aluminum is out. It's too thick. Now, what was the ID and OD of this? This is 15 millimeters OD, 10 millimeters ID. This is 10 millimeters ID, 12 millimeters OD. So I think that this low carbon steel round tube is going to work well. I hope. Now, am I worried about this rusting? Because this is not like excellent steel. 12 millimeter OD. 12 millimeter OD steel tube. I love McMaster car. It's so good. All right, 12 millimeter OD. What do I want? So I want 10 millimeter ID. 12 millimeter OD. Stainless steel. Cool. How much more does that cost? Holy crap, that's expensive. Oh boy. How long? What is 0.5 meters to feet? 1.6 feet. That is so expensive. Okay, so it looks like we're going for this stuff. Let me get a Roboman opinion on this, because he's smart. He's got a big brain when it comes to material specs and crap. Wood, low carbon steel cause issues as a sealing surface. Don't know. Okay, maybe that aluminum was not out of the question. Rigid aluminum tubing. Okay, maybe this is introduced back into the thing, because that's a good point. Like, is this going to rust? And is the outer diameter of this steel like super rough? I don't know. And aluminum tubing is generally cleaner. What wall thickness for the tubing? I haven't decided yet. Slather that steel and silicone lube. Yeah, exactly. So this is already going to be a sealed component in the blaster, since it has O-rings sliding over it. Like, there's already going to be lube all over this thing, getting slid back and forth. Hey. But I'm not sure if that's enough to prevent against rust, and it's also like, or not this one, this one. It doesn't look like it has the smoothest outer diameter in this CAD model that they've got. Like, they don't have a real life photo of it. Like, does this have a thing for surface finish? I don't think it does. So, I don't know. Maybe you'd have to, like, polish it with sandpaper to make it smooth enough. Because, like, I don't want it to shred O-rings, you know, as it slides over that. Can you paint the cheaper steel tubing? I wouldn't want to deal with that for hardware kits. All right, I think aluminum is probably going to be the better bet here then. So what was this? This was half inch, so that's 13-ish millimeters OD. That's fine. And this was what inner diameter? 0.43. 0.43 inch. Which is this. What? I didn't want that. There we go. 0.43. So that's only 11 millimeters ID. That's not horrible. What if I look up 10 millimeter ID aluminum tube? Does that come up with various crap? It sure seems like it. Now, does this McMastercar? Does this come up with anything? Comes up with fittings, but not really. What if I search 10 millimeter ID aluminum? Nope. 10 millimeter ID, 20 millimeter OD is bad. That's 10 millimeter OD. That's not what I want. 10 millimeter ID. Or 10 millimeter OD, 8 millimeter ID. That's not what I want. Bunch of random crap. So, probably not. So, looks like I would be stuck with the 11 millimeter ID. Yeah, call it the hammer. Exactly. Just chunky piece of aluminum. I think that this stuff, this aluminum here, is probably the best bet. Like, it's the closest in diameter. And it doesn't have a massive OD, which is good. So, yeah, let's get this in there. And that's 6 inches long, and it's almost $5 for each 6-inch segment. Now, I'm not going to use all 6 inches, but that is going to cause issues with other crap. Sorry, not going to cause issues. There's going to be leftover material, is what I'm trying to say, because I'm not going to be using all 6 inches. So this is this crap. I love that you can just insert stuff from McMastercar into Fusion 360 with just like a click of a button. It's so nice. All right, so this is that polycarbonate tube that I was looking at earlier. That's 8 feet of it, but I don't think that's going to work out. So this is aluminium. So I'll make it aluminium. There we go. And then I will align that with that. There we go. And boop. There we go. So that's aluminium right there. So let's move that and that up here to old, I guess, just in case I want to keep that around. What was this ID? 10.922. How do you propel the projectile that's inside the silly shell? Don't you need some sort of supercore? So this is the Nomad core from Roboman. It's similar to like a Specs BZ, if you're thinking of like an Australian kind of HPA project, but it's a lot smaller. So this is essentially a dump core where you put air into it and then you turn off the air supply back there and vent it out a little bit, and then it just dumps all the stored air here out the front. So that's essentially what I'm going to be using it for in this setup. This is the Cosmic Nomad core by Roboman. Yep. Same as my HPA thing project. Yep. All right, what am I doing? I'm saving. Good. And now I need to drink water. That sounds great, Peter Lee. Enjoy the slab. It's a fun one. I like the slab. All right. So this needs to be that same length as that. So let's cut that and then get rid of this bit. Excuse me. So we got that. What is the wall diameter of this tube? Less than a millimeter. Now, is that going to cause issues? It said that was rigid tubing. And it seems smooth. So that's a pretty thin diameter. I mean, this isn't going to be under much bending load, honestly. I mean, I guess it might be under some, because it's also acting as like a guide rod for the bolt. I don't know. I think it will be fine. So this is 12.7 millimeter diameter. So let's get another McMaster-Carr tab open. I need O-rings. O-ring. ID of, what was it, 0.50 inches. So I actually want a little bit smaller than 0.50. Is that right? So we've decided that we're using this tube. What was the OD of this? Yeah, 0.50 inches. So half an inch. Now you don't want the O-ring to be exactly half an inch, because then it doesn't like correctly grip onto the thing. I could have sworn that we already use an O-ring in the hobby that's about this size, don't we? We do, don't we? It's a 0. It's a 0112? 0112? No, it's a 112 O-ring. Is that right? And then a 0 or 110 O-ring. Are these things that we use? I've got this here. That's the 016 that we use all the time in the hobby. But I'm looking for different. This is too thin, right? 0.326. Yeah, it's too thin. Or too tight, I should say. So that's the 016 that we normally use. I'm looking for something that has ID of closer to half an inch. So this is exactly half an inch here. But I want something that's a little less than half an inch. 012 O-rings. Those are what we use for rams. Can those stretch out to the correct size, though? I don't know. That's a 014. That's a 012. 012 is 3/8 inch ID. What's this? The 013. And maybe I want a thicker O-ring. So this is 1/16 of an inch fractional. I was 1/16, 1/8. So that's twice as thick. And then what was it? 7/16 this guy. 205 O-ring. What's this like? It's got a 69 in it. That of course means that's good. 0.699 inches to millimeters. Which is essentially that diameter there. So that would be fine, I guess. This is the 014. So this is the same thickness of rubber as the normal 012 O-rings I use. Not sure if I want to use those. 205, 013. Oh, right. This is the one that I was thinking of. Sorry. Not this one. This one was a little bit too wide. I wanted to look at this. 7/16 of an inch. What is 7/16 inch? 2 millimeters. It's 11.1125. And then what was the other thing? What's the OD of this? 1/2 inch OD, but what's the actual OD? Plus or minus a negligible amount. Okay, so this. So you would have 0.5 inch, 2 millimeters. So it would be stretching it out by like 1.6 millimeters. I think that'd be fine, wouldn't it? Don't know. Let's close that and that. All of that. So we got inner diameter, 7/16, 7/16. So these both have the same inner diameter. Now the thing with having a thinner O-ring is that it would be easier to stretch. However, it would also potentially be more fragile to like if the aluminum inner tube had issues, like scratching it up and tearing the O-ring. And I have space for this thicker one in the blaster. Like it's not an outer diameter issue that we're dealing with, it's an inner diameter issue that we're dealing with. So I think this would be fine. So I'm gonna bring this into CAD. We're just gonna double check this. Insert McMaster part number. Step. Oh boy. There we go. There's our O-ring. Resistant baloney. Copy paste. Boom. Appearance. I want this to be black. And I can align that to here. Is that okay? I don't know. How much does the normal barrel go against the 016 O-rings? A little bit. Not sure. Not sure if that's okay. Huh. I don't know. So this is the other one. What if I go back to that list? So go here, search that. I'll go back to that list of crap. Here we are. What was the next one up? This one. One that's exactly ½ inch. Let's see more details about that. So this is exactly. Oh, wait. Aha. Actual. It's a little bit thinner. Okay. How does that match up to the thingy? Insert. Make master car. Boom. Bam. Beep it up. Skibbity bop. Bottom bot up. There we go. Find. Copy. Paste. Copy. Paste. Hide. Appearance. Make it black. Align. Here. Okay. That seems a lot better. Okay, I'm actually happy with that. That seems fine. Because compared to how an aluminum barrel, like a Nerf barrel, seals up against the 016 O-rings, that's about the same amount of overlap, and these 016 O-rings up here against normal barrels, those work fine. So I think that's fine for me. I think I'm okay with that. And that's the same thickness as well. Would custom printed TPU O-rings work? I mean, I guess it could, but it's more work than having to do this. Also, I've never printed TPU before, so I don't really want to do that. Split body there. There we go. I want to copy and paste that piece there so I can have a second one. Beep, 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 beep. There we go. And all this can go up into the old section. Okay, now this new O-ring, I'm going to bring it in line with that. And get those down. Now, how much wiggle room do I want between these two things? This has an OD of what? 12.7. So let's make this an ID of 13.2 divided by 2. Does that give a 0.5 millimeter? No, it's 0.25. E5, is that right? Yes. 0.5 millimeter gap between those two bits. So maybe that will be good. Maybe make that a little bit bigger. 6.9, because 69 is funny. Okay, let's try that out. Let's see how that works. I need to check my Discord real quick, because it looks like the Breacher beta testers are beta testing the Breacher. Yes. Mm. Let's do this. Right. So I wanted this O-ring. Let's just copy and paste that. Here. Let's move that back a few millimeters. Maybe that's good. Cut this piece using those. And then I can make this just a hair wider. Minus 0.05 maybe. 0.1. Give this a little bit of fillet, but I need to take into account the print direction. So actually I need this side over here to have chamfer. That's probably fine. And then this bit, I can give like just a tiny bit of fillet. I'm not sure if that will even show up when it's printed, but it should be fine. There we go. Good. And then this I want to actually be a little bit tighter, just in case those O-rings try to come loose. And then the rest of this can be that same diameter. Cool. So combine that and that. There we go. And then these two bits should be up here in bolt components, and this bit down here should be here in Nomad Core. And now I actually want this to also be that diameter there, since we've decided on this tube. 69, very funny. Yeah, that's a really good diameter, because that's essentially the same diameter at the back of silly shells right there. 13 millimeters versus a hair over 13. So that seems pretty great to me. Let's just give that a 1 mil radius just for funsies. And now combine that. So this should function now, essentially. I'm going to save. So essentially, we've got this, and we've got the O-rings. And this is going to be sliding back and forth. 95 millimeters, but let's say they can over travel to 100. So it's going to be essentially doing this each time that fires. That seems good to me. Is this an AEB or is this HPA? This is HPA, this project. This is the Cosmic Nomad HPA core back here. And this is going to all be operated like this with pneumatics. With pneumatics. There we go. So yeah, pretty good. Okay. So now I can begin thinking about some other stuff. Such as, what's the outer diameter of this? That's 19 millimeters. Okay, so that's essentially the same as a plunger tube for a normal Springer. Now, do I want to make this back section thinner? Because that is a lot of like printed material there. And it seems like I could make that thinner. I don't know. I do not know. Oh, another thing that I can do is I don't need this whole thing on the side anymore. Because now that this is thin enough, I can just extend back this groove here and make this a stationary thing. This ejector only pivots so it can move out of the way of like a thicker plunger tube being here, but like I have the space now where I can just extend that back and get rid of this bulge on the side. So that's pretty great. Let's do that. Now the thing is that this piece here in this body shell are printed in the same print orientation. So I do still want to have a separate printed piece to be the ejector. Also for durability reasons. But it doesn't need to pivot anymore. It doesn't need springs. So that's pretty good. That's pretty snazzy. Let's model that next, I guess. So get here to bolt face. I don't need that dummy bolt face anymore. And we can just get this all hollowed out. So that goes like that, and that goes like that, and that, and that, and this, and boom. There we go. Now what's the diameter between that? Yeah, it's got like 3.5 millimeters of wall between the air path and the ejector groove thing. That seems pretty good to me. Yeah. I do think that this here should be filleted just a little bit. There we go. And what now? Do I have a... Yep, here we are. So even if words, even in this thing's fully extended position, like where it physically couldn't extend out anymore, it's just barely past the edge. So I'm not really concerned about making this no longer spring-loaded. So that's good. So what I'm going to do here is I'm going to extend this out 0.5 millimeters, and I'm just going to chop the tip off of that. And there we go. And then I can just use this as a cutting tool, I think, and cut that. Very good. Like that. And I can get rid of that spring, and that spring, and this whatever screw. And then I can get rid of all of this bulge, I think. So let's do that. Boop. There we go. A nice empty space there. This can be fixed up. There we go. And I can close that up. There we go. So now I've got a smooth-sided thing. Now, get that ejector piece back in here. I want to change up the shape of this a bit to be better for its new purpose. So let's get rid of that and that. So let's move this back a bit, maybe. Oh, actually, what I could do is I could make this a symmetrical part. So like if it wears out on one side, you can just flip it around. That'd be pretty neat. Let's try that out. So that's that. Let's give this, I don't know, 20 millimeters of meat. Cut there. And the new thing there. Is this face parallel to that? Yes. So this is the origin of the 3D model. So this is essentially a perfectly vertical, perfectly centered thing that you can measure stuff up against to make sure that the angles aren't wonky or anything. Yep. Bump that out a bit. This can now be actually, no. I shouldn't bump that out a bit. I should bump that out a tiny bit because I don't want it to like break through the wall of the thing. Mag holder. There we go. Right, so this diameter here is 26. Actually, you know what? Yes, let's do that, and then I can just use that sketch that I made to trim that to be the correct wall profile. There we go. Cool. So we got that. Pretty snazzy. We want to give this a bit of fillet. So let's give it a 1 mil fillet. And then give this a 1 mil fillet. Very nice, very nice. So this is essentially symmetrical. So we'll be able to flip that around if it ever gets worn out, which is nice. And I don't want it to be merged with this green piece because then the print layers would rub up against each other. So instead, what I'm going to do is first I'm going to check this up against the bolt face. We've got modeled here. Now, is this thing's thickness a problem? It's got 2 millimeters of wiggle room there. That's tons. That's fine. In fact, we're going to make it like 0.5 mils thicker. There we go. Because why not? And then unisolate everything and show all bodies. There we go. And I'm actually going to scroll down here to the bottom and get rid of some of this crap. There we go. I'm going to dissolve the mirror. So now the mirror is no longer perpetuating throughout the part. So like if I had changed one edge, it would have automatically changed the other edge, but I don't want that, so I got rid of that. And let's make that a bit thicker. And what else? What else do I want to do? So I'm thinking to hold this onto the outside of the blaster, I'm going to put like a screw maybe, like head of and behind it. Maybe. But that might mess with the print orientation being bad for that, actually. How do I want to hold that in? I don't know. But for now, let's just make it in there. There we go. So now that's fitting in there. Beautiful. Looks great. Right about there seems fine to me. And then do I want this to have like a flange down there? That aligns better. Don't know. So I do need it to print with like this face up here on the print bed, because if I printed it with this face on the print bed, then that would be bad along the layer lines and it would snap. And I can't have it with this face up against the print bed because then the layer lines are lined up with this bolt face, and then you're going to get print rub sounds, which would be awful. Hello. Thank you for joining the chat. Here's a better view of it for you. Pretty snazzy. And this is definitely going to have a stock at this point, like extending out the back. Right, so what do I want to do here is a good question. Oh, also, this HPA pneumatic cylinder thing here, I think that can be moved up a bit once I do some other stuff. And also, this tube here doesn't necessarily need to be centered with this thing. Oh, that's the wrong view. I might be able to, like, curve down the air path just a little bit, so like it bends up as it gets towards the end. And that would give a little bit extra space to do funky stuff with keeping the pneumatic cylinder like right above it to line it up better with the blaster shell. I don't know. Stuff worth considering. And I'm actively considering it now. I think that's actually exactly what I do want to do, now that I've thought about it. But I'll do most of that a little bit later. For now, I just need to find the parts of the air cylinder and separate those out. So real quick, we're just going to do some wacky stuff here. HPA thing parts, we're going to make a new folder here. We're going to make this new pneumatic cylinder. And the thing is, this isn't actually the cylinder that I'm going to be using. This is a shorter one. I'm actually going to be using a 100 millimeter movement piston that's also a little bit wider. This is a 11 millimeter OD. The one that I'm planning on using, I think, is a 16 millimeter OD or 17 millimeter OD. So it's going to be a little bit thicker. So I need to take that into account when I'm like figuring out where I want this to be positioned, because it's going to change a little bit once I actually get the new thing in hand. Simple air hose. There we go. I think that's all the parts of the pneumatic cylinder. So those are all the valve and crap. And we've got the NPT that connects the valve to the stuff. We've got the screws that hold the grip in place, and the switch, and a spring for the trigger. And this is the pneumatic cylinder, and this is crap for the grip. And this should go here. There we go. So now we've got the pneumatic cylinder separated out. All of these parts to make them visible. HPA. So I'm going to rename this to grip. So that's the grip. This is the nomad core. This is the pneumatic cylinder. That's the ejector. Grip. Magazine. Angle stuff. And bolt components. I'm just going to make all the parts visible and save. Very good. Yes. All right. Pneumatic cylinder. Right. So do I want this to be moved? I want those in there. Expand that. Now there we go. So this is not the same cylinder that I'm going to be using in this blaster properly, but it's good enough just for mock-up right now. So I was thinking like having it above the air tank, like there. And then does that have enough wiggle room where then all of this could be moved down a bit? It's like off-center on the bolt face. It does. Interesting. Very interesting. Cool. That's worth considering. It's like having those two aligned like that would make this a lot easier to make the bolt for. Huh. Interesting. Cool. We'll come back around to that some other time. Yep. All right. So what am I doing now? Got that. We got this. Very good. I'm gonna figure out how to attach the ejector to the rest of the body of the blaster. So it's printing on that flat face there, which means its strongest screw hole position is through. Oh, wait, couldn't I just jam screws through the bottom? No, that wouldn't quite line up. That was a good thought, though. Is a higher capacity magazine possible? Possible, yes. Am I going to make one? Probably not. I'm going to leave it to someone else to make a drum magazine and like a double stack coffin style magazine, like double stack that then goes to single stack. Like stuff like that is definitely possible, but I don't want to dedicate the time to make it. Because it's a big old pain in the butt. Yeah. So maybe I will just put screws in through the side. So that's 4mm there. That's a pretty thick wall. Not sure. Oh, also, this. That's a good point, actually, is that these should not have that flat surface there. I need to change up the shape of this ejector. So that wedge shape that this has got, that's fine for the surface that the shell hits up against. That's actually what you want there, but like it should be straight along this bit here where it connects to that body piece. Magwell stuff. Mag holder. Here we are. So what I actually want here is I want to make this hole go bye-bye. And then I want this to be visible. I want to make a sketch. I want to find that by projecting that thing. That's actually not very helpful. Why did it not fully project the thing? Is that right? Is that the wall? No. Neither of these are the wall. Why is it? Oh wait, that one's the wall because it's a bit further up. Cool. So this thing here, back all the way to there. So anything past that point is what I want there to be a flat surface for. And what I can do to get that actually is I can just cut that along that face there. And then this I can just extrude a new body there, get rid of that, bring this out. Boop, 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 boop. There we go. And I can round that off just a little bit. Okay, maybe a little bit more. Yeah, that's about right. And give these 1mm chamfers, or fillets. And there we go. That's a bit better. So now it's got a flat face there for when it is connecting into the surrounding body piece. So now I can go back into mag holder. I can these bits go away. Make these bits go away. And I can extend this out by minus 0.3 millimeters. There we go. Ejector. And there we go. That's a bit nicer. So now it's flat surfaces that the printer will be able to support when these body pieces are printing vertically. Huh. Yes. Yes. Sorry. My mind is wandering a little bit right now. I need more sleep. I was up until like 1:30 a.m. or something like that last night after working on HPA stuff for hours and hours and hours. Yes. All right. What was I? Right. So this thing. How do I want that to attach? I think maybe I put a bulge here anyway. So I'm gonna put this like 2 millimeters out, and another 1 mil. Bring this back minus 0.5 mil. Trim the corners. Bring that back. Extend this out by 3 mils in each direction, and then bring this here. Is that 3 mil? Combine that with that. And then go back into just the mag holder. Here we are. And then extend this backwards. Ejector. I'm going to bring that up into this folder. Get into the cross-section view of just the halfway point. There we are. Off to go work on your car. Yeah, enjoy it. Thanks for watching. All right, what was I doing here? So this is a wall. I need this to be that minus 0.5. And then this can be filleted by 1. This can be filleted by then what? That maybe go to. Because this is going to be printed vertically, I want to maybe give this a slightly different shape. So I actually want to give this like a to there, distance and angle, flip again, 30 degrees. 30 degrees, 3.5 millimeters indent. 3.5, 30 degrees. 30-degree angles tend to print better than 45-degree angles when you're printing them vertically like that. Give this like a little bit of a fillet. Maybe extend these out just a little bit more. There we go. And then give this bit of filleting. So this looks kind of similar to that other wedge that I've got on the other blasters, but a little bit nicer. Not as big, not as bumped out as much. Bit sleeker. Now that can just pop right in there. Yeah. Good. Now, I was planning on putting in screws from the top down like this, but I actually think that putting them in through the side there would work a bit better. So I'm going to muck with the shape of this just a bit. So we got this. I want to have it be like that. So when the shells are hitting this, I don't want it to just be screw heads that are supporting it, like preventing it from flying off. So I have this little bit of overlap between the orange piece and the green piece here, because the forces are going to be hitting up against this face here. The forces are going to be transferred through this point here, as opposed to through the stems of the screws, which could cause issues if I had done it that way. So let's go there. Put this like that, maybe, or like yeah, that's fine. Cool. Now, how thick is that? 5.3. Cool. One of the things I'm missing in this file, which I'm going to grab from the Breacher file, is I don't have my little screw hole cutting tool jig things. So let's grab those. So we go over here, got my miscellaneous, screw reference, copy, and paste over here. Boom. Waiting for Fusion to stop throwing a fit. There we go. Very good. Did I not copy and paste over the parts? Was it crashing just trying to switch between the things? Let's try that again. There we go. Okay. Oh, wait, what? There's two of it. Oh, I had already copied and pasted it. Alright, cool. Screw reference. Bam. Miscellaneous. There we are. Screw references. Miscellaneous. Here we are. And I need a number 4 by 3/8 screw. So let's copy and paste that. There we go. Now I want to move this. Correct orientation. And I can just use the point-to-point moving tool to move it there. Beautiful. So that works out fine, and that gives me plenty of room for it to fit. Very good. Last thing that I want to do here is use the rectangular pattern tool to make even split of this like that, and I'll delete the middle one. So something like that seems good to me, and then I can delete that middle one and that one, and then use these two cutting tools to actually cut the screw holes into the bit. So there we go. And I can dissolve that pattern so they don't change each other if I move them. Beautiful. So I've got 2 screw holes there. That doesn't look bad. Looks fine. Just fine. Cool. And then does that look durable enough from this point of view? That seems about right to me. Cool. Very nice. I'll make these 0.5. I'll make this a 1.5. So it's easier to screw in. And there we go. Beautiful. Alrighty. Nailed it. Nailed it. Cool. So that's the ejector done. Very good. Yeah. Cool. I think that I think I'm going to end the live stream pretty soon, right after I respond to this new comment that just came in. Hi, I'm new to the channel and just saw your vid about the Breacher. How much was it inspired by Spring Thunder? And why do you use rubber bands instead of springs for shell locking arms? So, answering your second question first, I'm not using rubber bands permanently for the locking arms. I'm just using the rubber bands as a temporary solution to see how much spring I need to put in there. So once I've found out that the rubber bands made it work correctly, as in they acted as temporary springs just for testing, once those are done, then I will switch them to proper coil springs so they work better when the blaster is fully finished. Yes, Timbit, you can ask a question. Answering your first question regarding if Spring Thunder or if Breacher was inspired by Spring Thunder, not really. Like, as much as the thing is, Spring Thunder is essentially the only tube-fed Nerf shell ejecting shotgun that exists today. The Sobek also exists, but the Spring Thunder is the only one that's released. So, like, as far as going, hey, I wanted to make a tube magazine shotgun blaster, I guess that it could count as like being inspired. But in terms of like functionality and use case and just like looking at the Spring Thunder, it's barely any. I think that I looked at the Spring Thunder, like how it attaches the plunger tube to the bolt face once, and I said, I don't want to do it that way. And then I think that's pretty much the only time that I've looked at the Spring Thunder. Oh, and I also looked at how the Spring Thunder lifter works a little bit, but I didn't end up using anything like that. So not really inspired by the Spring Thunder at all. Now, on the other hand, Breacher is a lot more inspired by the Sobek, Sobek, which is a blaster by Raijar, Rraijjar is the designer of that. He has never released that blaster, but he gave me a lot of advice regarding how to make the lifter work. And, you know, whenever I had a little question like that, I would be like, hey, how does the lifter work? And he would give me some advice, and also some advice regarding the extractor. So as far as that goes, I would say that it's more inspired by the Sobek rather than the Spring Thunder. However, even with the Sobek, it's not massively inspired by that. Like, the lifter mechanism is pretty similar to the Sobek, but it's accomplished in different ways. So the vast majority of Breacher is more so just my own work or being inspired by previous blasters that I have made. Like the shell stop arms, I was just trying to figure out a good way to do it, rather than it being directly inspired by anything in particular. The printed priming arms were inspired by my low hardware Talon-Claw U blaster, where I went, hey, printed priming arms, those would work well. And that would make the hardware kit a bit cheaper, and you wouldn't have to deal with like machining the priming arms to have the notches to activate the shell stops. Stuff like that. And Breacher, this version of Breacher, is also vaguely based upon the Battle Axe, which is another one of my blasters. So like this outer profile is sort of similar to Battle Axe, and like the bolt face was a copy and paste of Battle Axe that I've then like chopped up and modified so much. But originally it was a Battle Axe part. So yeah, that's that. Timbit. I'm designing a silly shell mod for the Boomdozer currently and working on the shell ejection. Do you have any recommendations on how to eject the shells? I already have some exposed paddles at the front of the drum, but I'm not sure how I'm going to push them in to eject the shell. Ejecting the shells for Boomdozer drum. That's a good question. I don't know. Like, if you wanted it to be automatic shell ejection, you could sort of like have an arm that pokes into here. So let's say that this is your drum, and you've got your shells, and you've got some sort of mechanism that is preventing the shells from flying out. So let's say that you've got a lever arm of some type, where if you hit that, the shell comes out. What you could do is you could have a corresponding arm on the top of your cylinder, or on the top of your the blaster itself, which holds the cylinder. And then when you rotate the drum, this arm is hit by this other arm, this hook, and trips that, and then automatically ejects the shell. So actually that would be down here, because you wouldn't want to eject it while it's in the chamber position. So your arm and thing would be down here on the side, presumably. Now auto shell ejection from a cylinder, I'm not sure how useful that is. The shellfish does have that, and that's accomplished really well on that blaster, and I think that is extremely good on the shellfish. However, adapting that to work on a boomdozer, I'm not sure how well you could make that work. You would have to print an extra piece that attaches to the outside of the boomdozer to have the shell ejection system from the shellfish work on that. Now, if you've just got a manually operated thing to eject the shells, I think that just having manual shell ejection for each chamber would work fine. Just a button or a lever that you push on to eject each shell as you're reloading the thing. I think that would be fine, honestly. Right now I have a printed holder like the wild style and a lever that pushes in from the middle. I don't know if I have space to push forwards. Yeah, I think that thinking through this a bit. The thing about boomdozer drums is that they're not removable from the blaster, so it would be permanently on there. So I think that would be fine to have it so that I assume that boomdozer has 6 chambers. So there we go. I assume that would be fine to have a separate ejector lever on each thing. That you just hit by hand whenever you want to swap out one of the shells. So your reloading step would be advance the cylinder by 1 step, slam the lever, put in a new shell, advance the cylinder by 1 step, slam the lever, put in a new shell, stuff like that. But what you could also do is you could have I'm not sure how much space there is in the middle area here between all the chambers, but what you could try to make fit is if you have the ejection levers on the inside here, sort of hidden inside the cylinder, and have them all pointing towards the middle axis. And then you could have a separate sort of conical shaped thing. Wow, that's a bad circle. Sort of conical shaped piece. So this is a cone. And then have elastic on this to spring load it. So whenever you push in this middle piece, it pushes down all of the spring ejection levers. So what you could essentially do is you have your how do I draw this? So this would be a side view of the cylinder. So this is looking at it from head on. This is looking at it from the side, where this here is the muzzle of the blaster, and this here is the handle of the blaster. So you could have it so you've got a blast button, for lack of a better term, that you just press down on the front of the blaster, and then all the shells just fly out the side. So you push this in, and that trips all the levers, and then all the shells just fly out the side. That could work. But honestly, I think that just having manual shell ejection on each individual chamber sticking out the side of the cylinder, and you just press it with your thumb or something, that would work fine for a boomdozer. Going back to chat, Pac-Man, I got scammed out of a Spring Thunder, so I'm very excited to get a tube-fed shotgun from the creator and shop that I trust, especially with silly shells. Thank you. Appreciate it. Yeah, the thing with the Spring Thunder is also hardware sourcing for the Spring Thunder has always been a bit iffy, from what I understand. It's always been a bit hard to find hardware, and the hardware has always been pretty complex, pretty expensive, and lots of custom bits to it that only you can get if you get it from a shop that can wind their own springs or get laser cut, perfectly sized steel priming bars and crap like that. The thing with Breacher is that the hardware is a lot more off-the-shelf stuff that every other blaster in the hobby uses. Like, it uses the same plunger tube as every other blaster. It uses printed priming bars, so you don't need custom ones made out of metal. Lots of that stuff. So I think that Breacher should be easier to source. And therefore, more reputable shops are going to be carrying it, which is good. Hey, Silly, just finished my slab this weekend. Fully patchy and works really well, even with B-Car. Awesome. Glad to hear it. Enjoy your slab. So, yeah. That's pretty much that. Oh, yeah. Timbit, you're right. Mentioning that blast button idea for the cylinder, launching all the shells out at the same time. You're correct. Some of the shells would be blocked by the shell of the blaster around them. That's a good point. In that case, I think just having manually, like a button on the side of each cylinder bit would work fine, just to eject that one chamber's shell out the side. So assuming that this is your cylinder, you've got your shell here, and your shell would be visible out the side because it's a sort of, I don't know, it's got a, if this is the head-on of your chamber, it's got these sort of semicircle cutouts on it, where each side of a shell is already open to the air. So the shell is already like this, essentially. I think that having that like this, and then just having, you know, a button on the side, like a, I don't know, like a button with like some texturing on it. Just mash that in, and then the lever kicks out the lever with its pivoting axis, kicks out the shell, and then the shell comes flying out of the blaster. I think that would work fine. I think that would work just fine. So yeah, just essentially taking the wild style mechanism, and words. Man, I'm trying to use my brain here. So this is the muzzle end up here, by the way. So having a button here that you just press in, and then it kicks out the back of the shell a bit to pop it out of the blaster, sort of like the mild style mechanism. I think that would work just fine for you. Just having a button for each one of these chambers to press in and then eject the shell. So yeah. Yeah, so having the lever behind the shell with a button to press it, as opposed to having the lever sticking out the front of the shell, I think that would work better in the space constraints of a boomdozer. So yeah, that's essentially all that I've got for you guys today. That's the live stream. So I'm going to keep chipping away at this fully automatic silly shell SMG shotgun full auto blaster thing. That's HPA. I'm going to keep chipping away at this. And I don't know when I'm next going to do a live stream. Might be tomorrow. Might be months from now. Who knows? But I'm going to keep working on this thing. That should be good. So thanks for tuning in. And yeah. I'll see you guys again some other time. Alrighty. That's all from me. Alright. Have a great rest of your day.